I will go over some problems here, do a couple of problems with the inverse stuff, and then as you guys, I got a bunch of stuff to pass back to you. After that, then I'll discuss with you exactly what's going on with the test. Yes, Ms. Maddie, you probably want that copy. I left one in the bucket for you.
Okay.
I think so. You know what, why don't we do that graph thing tomorrow, because this is a little bit more important. We can get the graph stuff, we can get that going again later.
Wait, what is this?
That's what we did yesterday.
Oh,
All right. So what do you guys have from yesterday you want to take a look at? What we got, Mike?
not that part. Morning. Ow, you just
14? Sorry, I thought I had this open.
17, 18.
Now, yesterday when we talked about these style problems, suggestion that I gave you guys, whenever you had trig functions that were written in terms of two different ones, like on number 12, my suggestion was that you always want to write it in terms of the lesser degree problem. So number 12, I took the sine squared and wrote it as 1 minus cosine squared. What do you think I'm going to write sine squared as here? Same thing, 1 minus cosine squared. Whenever you have two trig functions, one of them squared, the other one is not, write it in the lesser of the two, or the lesser degree. So you have 2 times quantity, 1 minus cosine squared x plus 5 cosine x plus 1 is 0. From there, I'm going to go ahead and distribute, just like I did yesterday. I get 2 minus 2 cosine squared x plus 5 cosine x plus 1 is 0. At this point, does everybody agree I have 2 plus 1?
No.
Okay. So I wind up with negative 2 cosine squared x plus 5 cosine x plus 3 is 0. Which means I'm going to have to factor this. When I go to factor this, I'm going to treat this as a leading term coefficient that's not equal to 1, but I want that leading term coefficient to be positive. We always factored with a positive value of a. Now, in order to make that a positive value of a, I would basically have to move everything from the left-hand side to the right-hand side. Therefore, it changes all of the sign values. Everybody agreed on that? Becomes positive, negative, negative. So if I add 2 cosine squared, subtract 5 cosine, subtract 3, I get the following. 2 cosine squared x minus 5 cosine x minus 3 is 0. I'm going to use the trick of what we call U substitution for the cosine of x. Yes, sir?
Can you just pull the 2 cosine out of 2 cosine squared?
What do you mean?
Like,
Are you trying to do just a GCF or something?
yeah.
Treat it like you would a trinomial, because right now it's set up as a trinomial with degrees going down in 1 by 1. It's setting you up for factoring right off the bat, because there's 3
I
terms.
knew it was factored, but then I tried to factor it out, and I like put everything as negative, and that didn't work, so that's the only way I could think about it.
Did you write it as U?
No.
Write it as U. Because if I let U equal the cosine of x, then all of a sudden it looks so much easier. 2u squared minus 5u minus 3.
Did you get another version of Friday too?
Oh, the extra of the simplifying stuff? Yeah, I have it. I'll get it for you.
Okay.
Okay. Now, in this case here, again, what I'm doing is using that trick called U substitution. I'm letting something real crummy looking look like something easy to work with. So now I just take it and factor it like I would. 2 times negative 3 is negative 6. What times what is negative 6 that you add together to get negative 5? Well, negative 6 and positive 1. Okay. Write it out, group it. 2u squared minus 6u plus 1u minus 3 is 0. Now, in order to save paper at this point, I'm going to rewrite u as the cosine of x again. Two cosine of x plus 1 equals 0, and cosine of x minus 1, or minus 3, excuse me, equals 0. I've taken my two terms and I set them equal to 0, just like I moved with every other factored problem that we've ever done. Equation on the left, I've got cosine is going to equal negative 1/2. Which triangle am I going to be in to get a 1/2 for cosine? 30s or the 45s? 30, 60. Which one of those angles gives me a cosine of a half? The 60. So what is that in radians then? Pi over 3. So our reference angle is at pi over 3. And I'm looking for cosine to be negative. Which two quadrants has cosine negative? 2 and 3. Remember cosine's your x value? It's 2 and 3. So the reference angle of pi over 3 within the second quadrant is going to get me at 2 pi over 3. In the third quadrant, it gets me at 4 pi over 3. I believe this problem was within one revolution, so all I have to do is list out all possibles. So I don't have to worry about anything else on that one. And then on the other one, I have cosine of x is going to equal to 3. Does that ever occur? No. So there's no solution on that side. And that happens from time to time. Again, don't need a calculator for any of this. Right? It will be all non-calculator. Okay. What was the other one you guys were talking about? 17? Is that what we're 17 is 17. You're going to do the exact same thing I just did in 14, but instead of with cosine squared, I'm going to set it equal to 1 minus sine squared. Okay. And you do the exact same thing, Richie. On 18, there's a little bit different thing to work with. In number 18, you are automatically set up with two terms. As soon as I just have two terms, I'm going to want to do and work with GCFs right away. So what's the GCF of 2 cosine x and 4 cosine squared x? 2 cosine. So I'm going to factor out a 2 cosine right away, and I'm left with 1 minus 2 cosine of x. My two terms then, when I set them equal to 0, I get 2 cosine of x is 0, and 1 minus 2 cosine x is 0. On this equation, I'm looking for where is cosine of x equal to 0. Very good. This is a very big issue that's come up in both of the other class periods so far today. Whenever you have a trig function that's going to be equal to 0 or 1 or negative 1, you're always looking where? Quadrantals. Unless you're looking at tangent with 1, you might get a 45. But that's one of those things. Whenever you have cosine or sine equal to 0, that means you're looking at your quadrantals. You have to remember that your ordered pairs work that way. Your ordered pairs go cosine, sine. So it's 1, 0, 0, 1, negative 1, 0, 0, negative 1. Cosine is 0 at pi over 2, and 3 pi over 2.
3 pi over 2, because it'd be y over r, and then since y is negative 1,
cosine is the value of x. Where's cosine 0? Cosine 0 right there. Okay. And then on the other one, I get cosine of x is 1/2 again. Subtract 1 divided by -2. And I think we just did 1/2 a second ago. Wasn't it pi over 6? And it was positive, so we get pi over 6 and I'm thinking 30 degree, yeah, so, yeah. I was thinking the 30 degree angle, yeah, I was thinking sine, yeah, so it's pi over 6, and then cosine's positive, first, fourth, so pi over 3, 4, yeah. Wait. Yeah, 5 pi over 3, sorry. I forgot. It's what happens when I don't draw a picture. Okay? I know. Rich, did you figure out 17 yet? Okay. Thought I'd give you a head start. Which half are you at? Remember, whenever you have cosine squared, then a regular sine value, always write it in terms of the lesser degree. It's going to be, because you can use you're using the Pythagorean identity here. Two minus 1 is 1. Change your signs. Good factor. I'm just shortcutting this a little bit here. Instead of we're coming out. 2 times -1 is -2. To get to a -1 would be -2 and positive 1. Did you forget your signs?
No, I was doing this problem when we were supposed to be doing the other problem.
Oh.
I was asking a question because I was like,
Oh, you're like, wait.
this isn't what it's going
Whereas sine -1/2, I'm at 30, so pi over 6. Sine being negative is 4, 3, 11 pi over 6, 7 pi over 6,
and pi over 2.
and pi over 2, very good. For sine being positive 1. So I put the pi over 1. Okay. You guys are probably so sick and tired of trying this by now. One more time.
We were sick of geometry. We were sick of triangles all of last year too. So I mean, it's just like triangles part 3.
Yeah. It's like the bad sequel.
Yeah.
So this is going to be where it's -1/2. Sine is at 30 to give me 1/2. So that's pi over 6 for the reference angle. But I'm looking for the negative. Sine is negative in the third and in the fourth. So I just bounce it down where I had the 7 pi over 6, 11 pi over 6. Sine is equal to 1 is on your quadrantal. 0 and 1, and that's pi over 2. Okay. Pass up that work. I want to do a little bit of work with the inverse stuff today, and then kind of go over the rest of it with you, the rest of the stuff here in a second. What I want to do is work with you guys in how we set and solve the equations again, dealing with inverse trig functions. We did some stuff similar to this when we did the inverse trig functions back in chapter 13, but we didn't have to do all the moving of numbers around to get to it. So in 7, I've got 2 cosecant x plus 17 is 15 plus cosecant x. Does everybody agree that we have variables on both sides of the equation? All right. What do you do? Subtract what? Okay, what else? The other cosecant. Think of it this way. These are two variables on both sides of the equation. Pick on the little guy. Move everything from the right to the left. Subtract the 15 and subtract the cosecant of x. So I wind up with cosecant x I'll get there. Plus 2 is 0. All right. Now I've got it equal to 0, which means I got to move the 2 back. So I have cosecant of x is equal to negative 2. Whenever I'm left with an inverse trig function on one side equals something, to undo the inverse trig function, you just basically take the inverse. So what I'm doing here is I'm going to take the inverse of this side. What's the inverse of cosecant? Sine. What's the inverse of negative 2? Negative 1/2. Now you're back to something that makes a little bit more sense. We get back now to sine of x is equal to negative 1/2. What triangle am I in? 30 again?
Yeah.
So I'm at 30 degrees, so I am pi over 6. And what quadrant is sine negative? 3 and 4. So if I pi over 6 for the reference angle, being the negative value, that gives me what? 7 pi over 6 and 11 pi over 6. If not anything else, when you guys get to pre-calc next year, you're going to be really good at reference angles. Really, really good at them. Which means you're all going to forget them by the time you have to go use them again. So don't forget them. Okay? Take a look at the one above that. I think it's the cotangent one. Yeah, number 5. What I want to do with this one is I want to use that u substitution again. All right, let's let u equal cotangent of x. Okay, I'm going to let u equal the cotangent of x. When I let u equal the cotangent of x, I'm going to get 2u to the 4th minus u squared minus 15. I love it. When we were at the old building, we had the movable walls between us, and my room was right next to Seb's room. Two of us are kind of loud. I don't know if you ever noticed that. And if we ever had somebody fall asleep in class, we would both play really loud music and we'd yell at each other, "Who'd you get?" So we would yell back and forth. Dylan was napping.
Dylan.
Anyway, so take a look at what we have here. Does everybody agree that's a trinomial? 3 terms? Does everybody agree that the degrees are going down by 2? So it goes 4, 2, then nothing? When it does that, you can treat it like you would x squared, x, and constant. You can still factor it the exact same way that you would before. So now, what's 2 times negative 15? What times what is negative 30? but you add together to get negative 1.
Negative 6.
Negative 6 and 5. So 2u to the 4th minus 6u squared plus 5u squared minus 15 is 0. Again, I'm setting this up to factor by grouping. I'm splitting out that middle term so I can take GCFs. I find that to be one of the easiest way to factor these things. When I get to here, then my two GCFs, 2u squared, and then I take out a 5u, oh, excuse me, just 5. And I have that. Is everybody okay with that? Now, can I go back and rewrite it as cotangent squared for those? Because I used that u substitution. U is equal to cotangent. Just saving paper. So I have 2 cotangent squared x plus 5 is 0. And cotangent of x, or cotangent squared of x minus 3 is 0. I'm left there. Again, I'm going to move everything to the one side to get the trig function alone. Subtract 5, divide by 2. After I do that, prior to taking my square root, I like to go ahead and do my inverse to put it in terms of something that makes sense. What's the inverse of cotangent? Tangent. What's the inverse of negative 5 over 2? So you just inverse both of them. Yeah. So you have tangent squared. By now, you're probably noticing that the tangent squared of x equaling a negative 2/5 doesn't fit on one of our triangles, does it? No. So here's what happens. This, on Thursday, will equal something that's happy, that'll fit on a triangle. For right now, I'm just going to leave it, okay? We have to hit what's on the calculator. You add pi. It's very, very simple. I'm going to go and look at the cotangent minus 3 equals 0 and see if I can find a value that works on a triangle. You agree I got to add 3?
Yeah.
Inverse? What's the inverse of 3? Good. And now you're probably seeing that you're going to get something that works out nicely. Tangent of x is going to equal plus or minus 1 over root 3. What triangle is going to give me a tangent of 1 over root 3? 36. Tangent is opposite over adjacent, so wouldn't that be at pi over 6? And the 30? Opposite over adjacent, 1 over root 3. So at pi over 6 being my reference angle, I'm looking for all possible values here because I'm doing positive and negative. I just have to find the reference angle in each of the 4 quadrants then for pi over 6. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And those would be my 4 solutions. Over here, again, you'd have to get the decimal equivalency and work with it. It's not a difficult process to do, but on the test on Thursday, if you have to factor something like that, it will fall on the triangle. Okay? So you'll get solutions you can find. Does that make sense why I stopped and didn't bother to finish that? What I want you guys to continue working on now, while I pass back a bunch of this other junk, I want you to do numbers 3 through 12. Okay? I want you to do numbers 3 through 12 on that side. We'll check those tomorrow. Yeah, on the B side. Now, as far as the test is concerned, what is on the test? The test itself is going to have what we did way back when, the graph stuff, amplitude period. This stuff you guys did really, really well on. It was that quiz we took prior to spring break. Bless you. You guys kicked butt on it. You did really well. Okay? After that, we got back and we started, that's when you guys all got mad at me. Simplify, verify, solve, general, and solve on the interval. on calculator. Okay. When we get in here tomorrow, we'll go over any last minute questions on these solve equations. We'll quickly revisit graphing, amplitude period, what does all that mean again? Simplify and verify, I think I've given you just about every single possible ones that I can come up with, except for the ones that are on your test. Though you don't have those yet. They're all the same complexity that we've been working on. Solve general and solve in the interval, it's what we've been working on the past few days as well. Yes, sir?
It'd be cool if you like gave us like all the problems you could think of, and then you had to do just like boring ones on the test, like we already did them, but you didn't tell us what ones that we did.
It happens all the time. You guys just don't know that you do.
Well, and they're like years ago, so who remembers that?
Well, no, because you guys, I mean, to be honest with you, there's only a finite number of these types of problems that are out there, without getting too crazy. So, yeah, we'll do all that tomorrow.